Okay, so for an ideal pendulum, x double prime equals negative k over mx. And again, as we said just a minute ago, we have to find a function for x such that when we take its second derivative, we get a negative multiple of x, that negative multiple being a multiple by negative k over m. Okay? I think I had too many negatives in that statement, but I'm not going to worry about it. You get the idea. Okay? Well, we determined when I asked, what kind of a function has a second derivative, it's a negative multiple of itself. We got a good answer, cosine function. Or was it a sine function? Either one, it's true for both. Okay, so, over here, it's going to write a little bit of knowledge that we need. Okay? And if you've been through a calculus course, if you're rusty, fix that. Okay? You got to know this much, and you got to know the chain rule. Okay? A little bit of integration will help, but that's just a reverse of differentiation. You don't need much calculus, but you got to understand the concept. You got to understand that this function gives you the rate of change of this function at an instant. And this function gives you the rate of change of this function at an instant. Okay, you have to understand what that means. You should understand what that means in terms of graphs, and you should understand what that means, especially as we go through this course, in terms of the things you see moving around and stretching and deforming. Okay? Bombarding you with radiation in this lab. We don't bombard you with much radiation. Not till second semester. When you're strong enough to handle it. Okay, well, so we have this, which is going to be very helpful here, right? Like if k over m was 1, then we would have our solution, right? Okay? But k over m isn't 1. Okay? If it is 1 in one system of units, it isn't in another. So we're going to have to deal with it. So we first then have to understand the chain rule. So what's the derivative of the sine of pi t?
Yeah, I'll show you. I'll point you to the building.
Okay.
Pi cosine of
Yeah, it's a composite function, the sine of the pi t function. So f prime of g of x is g prime of x times f prime of g of x and all that stuff.
Wouldn't it be a negative?
No. No, the derivative of the sine is the cosine. Derivative of the cosine is the negative of the sine. Okay, unless I've got it backwards, which is always possible, but I'm pretty conversant with that one. Okay? I mean, I can't reverse things sometimes. It's out of carelessness, but I don't think I know what it is. So, okay, so anyhow, you have this, right? So what is the derivative of the sine of c times t? Where c is a constant number.
Same thing, but replace pi with c.
No pi involved. There's no pi in this.
I know, it'd be like the same thing.
Okay, okay, I didn't understand all your words. I didn't think you'd say anything wrong there. Derivative of the ct function is just c. Now, you got to know, again, chain rule, derivatives of power functions, derivatives of sine and cosine functions. Product rule and quotient rule as well. Those are just some basic rules of differentiation. Okay, and it's just a mechanical process, but you got to know the rules and you got to be conversant with them. So that when you see a problem that involves this stuff, and usually if you have a 5-problem assignment, one of them will involve the calculus. Okay, but you got to know the calculus when you get to it, or you won't be able to function. Okay, so anyhow, we have that. So our question now is, what would you take two derivatives of to get negative k over m times the sine of t? Well, just do this. Okay, take a second and calculate the sine of ct double prime. In other words, the second derivative of the sine of ct. Okay? Now come around, look over your shoulder, see if you're getting it. If not, I'll give you some hints.